Hello students, welcome to Young Cubs. We are continuing the chapter Properties of Materials and today is the fourth lecture. Today I will be teaching you about group 0 elements, which are noble gases or inert gases, and about compounds. Let's start. Now, children, noble gases basically lie in the last column on the right hand side of the periodic table. They are known to be in group 18. Sometimes when children are still young, learning about all the elements of the periodic table, at that time we just tell them that they are in group 8. And we also say that they are the group is also known as group 0, as there is no further capacity of their outer shell to gain or donate any kind of electrons. So the 0 capacity, hence group 0 also. Now, okay, the first element of the noble gases or in the periodic table is helium, then comes neon and argon. Okay, so these three are important for you to learn as of now, as they lie between the first 20 elements of the periodic table. Later, in the 9th and 10th grade, you will learn about krypton, xenon and xenon. Okay? All right. So, helium, neon, argon, krypton, xenon and radon. All right, children. Let's read. So, yes, so they are helium, neon, okay. Then they are monoatomic. What does this mean, children? That means when we studied about atoms and molecules, what did we learn about atoms? That they are the smallest particles, the smallest particle of any material or any substance or any object. Okay. However, they may or may not exist freely in nature. However, molecules are the smallest particles that definitely exist freely in nature. Yes, and molecules may be monoatomic. That means one atom, if it exists freely, it is known as monoatomic. It is a monoatomic molecule. If two atoms combine together forming a unit, they are diatomic molecules. Three forming together, triatomic. Yes, so most of the times atoms do not exist freely in nature. But if they exist, because they can react rapidly with anything around them. However, if they exist freely in nature, if it's a single atom existing freely in nature without reacting in its surroundings, they are known as monoatomic molecules. Okay, so noble gases are monoatomic, single atoms existing freely. They are unreactive gases. All of them are gases and all of them are unreactive. Tell me why, children? Because their outermost shell is complete. It is full. Okay, so they need not accept any electrons, they need not give away any electrons, or they need not share any electrons to react and form a bond with. Alright, so they are highly unreactive at room temperature and pressure, and that's the reason why they are also known as inert gases. Hope this much is clear. If you see this 2, 10, 18, they are all atomic numbers. Okay, if you in the next on the next page we will be making the atomic structure of helium, neon and argon. We shall see that the outermost shell is complete. Okay, and that's the reason why they are non-reactive. Okay. Before doing this, let's make the structure. Children, I want you to make your structure and then I shall share mine with you. Come on, please start. Here, children. Here is my figure. Here are my diagrams. Okay, look at helium. Okay, the first shell, the K shell is complete. That means it has attained its duplet state. It does not want to share any electrons because its capacity is over. It is not willing to give away any electrons because it's satisfied. Okay, so neither taking in, neither taking out. So that's what makes it inert. Okay, let's look at neon. Okay, 2 in the innermost shell, K shell. K is complete. L is also complete with 8 electrons. Okay, look at argon. 2 in the innermost, then 8 and then 8. So this is also complete and both neon and argon have attained their octet state. Let's see what period they lie in. It has one shell, so helium lies in period 1. Neon has 2 shells, it lies in period 2, and argon has 3 shells, hence it lies in period 3. Alright children, this is the structure of the first 3 noble gases. Hope this much is clear with you. Let's look at the other properties of noble gases. So helium, okay, it has an atomic number of 2. Its electronic structure, as in it has only the first shell, which is complete, which has 2 electrons. Okay, mass is 4. That means it has 2 neutrons. Melting point is minus 270 degrees and boiling point is minus 269 degrees. Okay, neon 10 is the atomic number, configuration 2 and 8, which is again the second shell is complete. Mass number is 20. Yes, so that means 10 neutrons, okay, minus 249. So it has decreased. The melting point is falling. The boiling point also, look here, is falling. Okay. No, boiling point is increasing and so is the melting point increasing. Sorry for that statement. The numbers are falling, however, the melting point is increasing as you go down. The boiling point is also increasing as you go down the table. Okay, argon 18, configuration 288, mass number 40. That means how many neutrons? 22 neutrons. Okay. So these are a few properties in terms of melting point and boiling point are the physical properties. Okay, if they ask you to write a short note on inert gases, all this is what you can mention along with what is mentioned on this page. As in monoatomic, unreactive or inert, lie on the extreme right of the periodic table. Alright, let's attempt a few questions related to noble gases. What trend is in melting point? What trend in melting points can be seen in group 8? That the melting point is increasing. Yes, what happens to the size of the atom as you go down? The size also gets bigger. Always, children. What similarity is there in the structure of these atoms? What is the structure? Their outermost shell. Their outermost shell is complete. Or you can write they have 8 electrons. 8 electrons in outermost shell. Okay, suggest why this group is called group 8. It is called group 8 because it has 8 electrons in the outermost shell. What predictions can you make about the melting point and boiling point of krypton, which is the next gas in this group? The same thing, the melting point and the boiling point will increase. Okay, get higher. They will get higher. Alright, children, come on, let's move on to a different topic called formation of a compound. So, children, what is a compound? Children, how are compounds formed? A compound is always formed with a combination. Compound is always a combination of a metal and a non-metal. Okay, compound is always a combination of a metal and a non-metal, or rather, to put it in easier terms, compound is something which has different types of atoms in it. Okay, so if I have a sodium atom which combines with a chlorine atom, then this is a compound. But if I have an oxygen, so this is a compound. But if I have oxygen combining with another oxygen atom, then it remains as an element only, because the atoms are the same. But here, since the atoms are different, it will form a compound. Okay, sodium is a metal, chlorine is a non-metal. What about two metals combining with each other? A metal, say tin and copper. When tin is a metal, yes, and copper is also a metal. When a metal and a metal combine with each other, okay, what is that called? When a metal and metal combine with each other, they are known as alloys. The alloy form the alloy name, when tin and copper combine, the alloy is called bronze. Yes, children? So, compound is the combination of a metal and a non-metal. So, let's learn how compounds are formed when two atoms of different elements combine. Okay, just for a little fun, I have just colored these atoms. Okay, let me take the first combination of sodium and chlorine, the next combination of magnesium and oxygen, and the third combination of aluminium and oxygen. Okay, now children, pay attention. There's a lot of basic concept that you need to understand here. Okay, now tell me, children, how many electrons are there in, let's do the first one. So, how many electrons are there in sodium? Sodium has 11 electrons. Na, Mango, Ali says, so the 11th one. So, I'll just draw the outermost one. So, the outermost one, because the inner ones are satisfied, we know. So, the outermost one has 1 electron. 11. Chlorine has 17 electrons. So the outermost one has 7, 2, 8, 7. Okay, so 4, 6 and 7. Okay, so now chlorine needs 1 electron to complete its outermost shell and get satisfied, whereas sodium wants to give away its electron. This electron sodium wants to give away, and this electron wants to, and this chlorine wants to accept the electron. So what they do is they bond. Okay, they bond. They bond with each other. All right, thus forming an ionic bond. Why the name ionic, children? Because if this sodium gives away 1 electron, okay, the negative charges will become less by 1 and it will acquire a positive charge, and any charged atom is not called an atom anymore, it is called as an ion. So that's why, okay, this turns into an ion. On the other hand, where chlorine, okay, it has 7 in its outermost shell, but it is accepting 1 electron. So the negative charge in the atom increases, no longer neutral. Hence, chlorine will acquire 1 negative charge. This also becomes an ion. Hence, after becoming, once they give and take their electrons, they become ions, and hence it becomes an ionic bond. That's the reason why, children, I told you that it is a compound is formed with a metal, with a combination of a metal and a non-metal. Okay, let's look at this one. Magnesium and oxygen. What happens out here? Magnesium, number of electrons 12. Okay, so outermost shell has 2 electrons. Oxygen, number 8. Okay, atomic number 8. So how many in its outermost shell? 6. Yes, children. Here, oxygen has a deficit of 2 electrons. Here, it has 2 extra electrons out here. Magnesium wants to give away the 2 electrons from its outermost shell. Oxygen wants 2 electrons in its outermost shell to get stabilized. These will move in here. They will bond. The 2 will bond. Okay, thus forming another ionic bond. So here, what is the compound called out here? It is NaCl, sodium chloride, nothing but your table salt. Here the compound is MgO, nothing but magnesium oxide. Now the third one that we are going to do is a little different. Okay, but see how these bonds also form. Aluminium. What is the electronic what is the electronic configuration? What is the atomic number of aluminium? Let's check. Here we have aluminium. It has 13 electrons. What about oxygen? It has 8 electrons. Let's see how it goes. 13 and 8. 13 and 8. So 13 means 2 and 8, 10. And so outermost shell has how many? 3 electrons. Okay. How many electrons in the outermost shell of oxygen? 2 required. 6 in the outermost shell. So 2 required. Now what exactly happens? What exactly happens out here is it takes these 2 and bonds. Now this aluminium and oxygen form an ionic bond. Here valency takes a very important, it has a very important role out here. The valency of aluminium is 3, correct children? The valency of oxygen is 2. How valency of aluminum is 3? Because it is willing to give away 3 electrons. What is the valency of oxygen? 2, because it is ready to accept 2 electrons. So what exactly happens out here? When we talk about valencies, the valencies exchange, as in how is the chemical bond or chemical formula formed? Aluminium takes up the 2 and oxygen takes up the 3. Okay, the valencies crisscross each other. Okay, they take over each other's valency. And what is the chemical formula now? It will become Al2. Oxygen will have 3. Okay, so this is the chemical formula of aluminium oxide. Understood children? We will learn more of these kinds later, but right now how ionic bonds are formed has to be clear with you guys. Okay, this is how ionic bonds are formed. Ionic bonds are always formed between a metal and a non-metal. But then what exactly happens with the same type of bonds? We shall look at it, but let's first look at the properties of ionic bonds. They form crystals. They are hard, and the compounds that are formed by ionic bonds are hard but brittle. They shatter, they crumble if broken. Okay, they have a high melting and a boiling point. They do not conduct electricity. Ionic bonds do not conduct electricity as solids, but when they are in their molten form or dissolved in water, they may conduct electricity via electrolysis. Okay, in solid form, they are not conductors of electricity, but in molten or aqueous form or dissolved in water, they conduct electricity. They are often soluble in water and insoluble in non-polar solvents. Right now, just understand they are often soluble in water. Okay, they have high vaporization. Okay, they fuse and solids. Okay, let me not cancel this. They fuse easily and they vaporize, form vapors easily. Okay, and solids are good insulators because they clearly stated out here they do not conduct electricity if they are in solid states. Hope this much is clear, children. These are all very, very important. I would request all of you to kindly make neat, proper notes so that it becomes easy for you to learn. Going to covalent bonds or covalent compounds, no, covalent bonds. I would rather call it a covalent bond. Okay, what is a covalent bond, children? When two non-metals, an oxygen and an oxygen, or a nitrogen and a nitrogen, or a chlorine and a chlorine, or a hydrogen and a hydrogen molecule combine with each other. They form a bond with each other. When two non-metal atoms form a bond with each other, they are their bond is known as a covalent bond. The word co simply means sharing. So the valent electrons are shared and a bond is formed. Alright. So if you look at this example of hydrogen. So children, we know that hydrogen has one electron in its outermost shell. It needs one more electron to become stable. So what it does is it and to exist freely, most important, it needs one more electron to exist freely in nature. So what they do is they go into a sharing mode. Here they move into a sharing mode. So it's like when the teacher comes to this electron or this atom, he will say, see, I have two. And when the teacher comes to this atom, you think, see, teacher, I have two. So this one scratches the other one's back, and the other one's back is being scratched by this one. So that's how, in sharing is caring is what covalent bonds believe in. They share and bond. But children, sharing bonds are always stronger than giving and taking bonds. So covalent bonds are always stronger than the ionic bonds. They cannot be easily broken. Okay. Look at, so here in this case, how many electrons have been shared? Okay, one from each. So this is how we write it. So the covalent bond has one bond. One sleeping line indicates one bond. Okay, so one each. Now let's look at this one for nitrogen. Okay, now what is the valency of nitrogen? 3. Okay, 5 in its outermost shell. It requires 3. So it combines with another nitrogen atom where they say that they form a pair of 3 electrons. When the teacher comes to this one, it says, see, I have in all, I have 3. I have 8 in my outermost shell. 1, 2, 3, 4, 5, and then 6, 7, 8. See, I am stable. When the teacher comes to this one also says, see, I have 1, 2, 3, 4, 5, and 6, 7, and 8. So here sharing is caring again forms a very strong bond. So 3 electrons shared. So here we have 1, 2, and 3 sleeping lines showing that it's a triple bond, triple covalent bond. Alright. Here, when we come to water as a molecule. Water also has a covalent bond, as in they share electrons. So oxygen basically requires 2 electrons to get satisfied to attain its octet state. Hydrogen needs 1. Okay, so what this hydrogen does is, look at this one here, they bond with each other. Okay, they take, when teacher comes to hydrogen, okay, it has one of its own and one that it is bonded with oxygen, and this hydrogen atom becomes complete. Okay, similar case with this one of hydrogen itself and one of oxygen it shares. So both when the teacher comes to both the hydrogens, they say, see teacher, we are complete. Now when the teacher comes to oxygen, oxygen said, I shared with you, you also have to share with me. So one of the hydrogen share, and that's the reason why hydrogen, 2 atoms of hydrogen bond with 1 atom of oxygen. So water also has a covalent bond. Covalent bonds are difficult to break as compared to the ionic bonds. Let's try a few more of covalent bonds. Ammonia. The chemical formula of ammonia is NH3. That means nitrogen bonds with 3 hydrogen atoms. So here we have a nitrogen atom. It has 1, 2, 3, 4 and 5 in its outermost shell. That means it requires 3. Okay, so here is a hydrogen atom which is willing to share 1. Okay, hydrogen is complete out here. We have another hydrogen here. Okay, which is ready to share its electron, and when teacher comes to this hydrogen, it has 2. When teacher comes to this one, it has 2. It comes to this one, it has 2. And then you may have another one over here. Okay, it has another one over here. So when teacher comes to this hydrogen as well, so they are complete. On the other hand, the ones that hydrogen already have, the one that hydrogen already have, they are willing to complete the shell of nitrogen when teacher comes to nitrogen. Yes, nitrogen has 5 in its outermost shell. So this one from hydrogen, say this one from hydrogen got 6th, this one another one from hydrogen 7th, and this one from hydrogen again 8th. Nitrogen is completed, hydrogen orbit or shell is completed. So by covalent bonding, okay, ammonia is formed. Let's look at carbon dioxide. Carbon. What is carbon? Okay, C. Okay, how many electrons? 4. Yes. Dioxide means 2 oxygen atoms. So we have 1 oxygen atom. Oxygen already has 6. It needs 2. So 1 it will take. 1 it will take from carbon. Okay. The other one, other oxygen. 1, 2, 3, 4, 5, 6, and here it will take 1 from carbon as well. So all in all, this unit as carbon dioxide also gets completed. It gets completed by covalent bonding, and all in all, a complete satisfied molecule. Alright children, so these were 2 examples of covalent bonding. Come on, let's work out this table now. Hydrogen chloride. Hydrogen requires 1 atom. Chlorine also 1 atom. Okay, so both require 1. Okay, what is it? Is it a compound or an element? It is a compound. Okay, and what is it? Is it what do you think it is bonded with? It is an ionic bond or a covalent bond? What do you think it is? So hydrogen basically wants to accept an electron to complete its outermost shell. Okay, so to attain its duplet state. So hydrogen is accepting. Anything which is accepting behaves or is called as a non-metal. So here chlorine is also more like is definitely a non-metal. Okay, hydrogen is also accepting, hence they bond with a covalent bond. Okay, and what state of matter is it in? Think, children, since it's yes, see, both both are in a non-metal state. Hydrogen also behaves like a non-metal, and so does chlorine behave, or chloride behave like a non-metal. Hence, non-metals, what we've studied about non-metals can exist in either solid, liquid, or gaseous state. So what do you think? Hydrogen chloride, which state would it be in? It is in its gaseous state. It's a gas. It's a colorless gas. Okay. Hydrogen. Hydrogen chemical formula H2. Remember, children, symbol is H, but available, or how does it exist in the atmosphere in a free state as H2. So chemical formula H2, it is same type of element, same type of atoms, hence it is an element. Okay. Bond is a covalent bond. Sharing is covalent, and hydrogen also exists as a gas. Ammonia. Chemical formula of ammonia NH3. We just practice the bonding. Okay, so this is a compound, and compound as two non-metals combining, so covalent bond, and this is also a gas. Oxygen, O2, it is an element. Bond is a covalent bond, and this is also a gas. Methane, it is CH4, sharing of electrons, one carbon atom bound by four hydrogen atoms. C requires four atoms or four electrons to complete its outermost shell. So this is a compound. Two non-metals combining, so covalent bond, and methane is also a gas. What about chlorine? Chlorine chemical formula Cl2. It is an element. Bond is a covalent bond, and methane and chlorine is also a gas. Water H2O. It is a compound. It is bond with a covalent bond, and this is in its liquid state. Nitrogen N2 is an element, covalent bond, and it is a gas. Carbon dioxide CO2, two different atoms, hence it is a compound. Okay, and bond with a covalent bond, and this is also a gas. Children, I think I made a misstatement. So a compound is basically not necessarily a combination of a metal and a non-metal. It is a combination of two atoms basically. So combination of a metal and non-metal is an ionic compound. So a compound is a combination of atoms, I would say, or different types of atoms. So I'll just change this. A compound is a combination of different types of atoms. Doesn't matter if it is a metal-metal bond or a metal non-metal bond or a non-metal non-metal bond. Okay? Sorry, children. Yes? Hope this table is good to go. All right, children. We'll call it a day over here. Thank you so much and God bless you all.